Right, I've got some water that's boiling over here. It's at 100 degrees, which is the boiling point of water at 1 atmosphere. Vaporization, we've got a liquid changing into a gas, and we need to reach that temperature for that to happen. I've got some ice water here, and I'm going to do something really crazy. I'm going to get this water to boil by cooling it down. To start with, very carefully, I'm just going to take it off of the hot plate and put a stopper in. Immediately you can see it's stopped boiling. I want you to realize as well that the temperature is slowly starting to go down. The particles are starting to move more slowly. The thermal energy is going down. I also want you to think about the gas that's above the liquid inside here. It wasn't just air. There was a lot of water vapor inside there. And so the quantity of water vapor inside here is still quite high. I'm going to give this just a few more seconds just to sit. And then I'm going to turn it upside down with the stopper inside, and I'm going to pour some cold water over it. And something really weird is going to happen. Alright, so I think we're about ready. Do this without burning myself. I want you to watch as I pour the cold water over it. And it's starting to boil again. So we are boiling this water by cooling it down. I'm not just cooling down the water though, I'm cooling down the gas above the water. We're decreasing the temperature of the gas above the liquid, so the pressure is going down, but also the amount of gas particles in here is being decreased because the water vapor inside there is starting to condense, change back to a liquid, so the pressure above this liquid is now less. And not only can we manipulate temperature to get something to boil, but we can also manipulate pressure. I'm going to get just a little bit more water. Right, I'm back with some more water and more ice, and I'm going to see how long I can actually get this water to boil. So this cold water is dripping past the liquid as well, so definitely that liquid is getting colder and colder and colder. The pressure inside here is getting lower and lower and lower. On Mount Everest, I don't even know exactly what the boiling point of water is, but the boiling point of water on Mount Everest is maybe 60 degrees Celsius. I'm just taking a wild guess there. But it's going to be less than 100 because the pressure up on Mount Everest is much lower. And it's quite logical. If you think about it, when something boils, the gas has to escape above the liquid. And when you reduce the pressure of the gas above that liquid, it's more easy for that gas to escape. In space, water boils almost immediately because there's no real pressure to keep those molecules together. Still boiling. Now, I don't need to use any tongs anymore. I can just hold this with my hands. Let's see if we can get it to boil, to get a bubble once more. There we go, there was another bubble. Let's see if we can get one more. There we go. Okay, so that what you saw, there was a bubble again of water vapor developing as it was boiling. So I'm going to take the top off. Let's see how low this temperature is. Now you're going to hear a sound as the air rushes back inside, and it's pushed on quite tight here. So we were able to boil this water by lowering the pressure. There's a diagram called a phase diagram that shows the relationship between pressure on the y-axis and temperature on the x-axis, and it shows how phases change between solid, liquid and gas as we change the pressure and the temperature.